Let's discuss a common data question on refrigeration. Uh, it's basically, let's read out the question. A refrigerator based on ideal vapor compression cycle operates in the temperature limits. So if I happen to draw the TS curve, okay, it basically looks like this, okay, and what is given is that the refrigerant enters the condenser as saturated vapor. Now, if you recall, I mean, it is given as 40 degrees Celsius and minus 20. So this is the 40 and this is the minus 20 line. Okay, the minus 20 degrees Celsius, the 40 degree Celsius. Okay, okay. And what is given more is that it enters the condenser. So this part is the condenser. It enters the condenser as a saturated vapor. So here is the point where it enters the condenser and it leaves the condenser. So this is a process that takes place in the condenser. It leaves the condenser in a saturated liquid. Then if you remember the throttle cycle, after that there is a throttling and then it enters the refrigerator or the evaporator, where it gets converted from liquid to vapor, and then there's a compressor. So we assume that in the compressor there's a isentropic process. So this is the process where I will start from the compressor as 1, 2 is the point at which it enters the condenser inlet, 3 is condenser outlet, and 4 is throttle outlet. So this is the vapor compression cycle in TS diagram. And 2 and 3 it is given that I mean the points which are clearly given that 2 is a point at which at the condenser inlet where it is saturated vapor, and so we have basically the points we have represented based on the given data. Now, and also the enthalpies and the entropy at these two temperatures, minus 20 and 40, both the liquid and the gas part is given in the table. So the refrigeration circulation rate, that is the mass flow rate, is given as 0.025 kg per second. So what is asked is, in the first part of this common data, is that the heat rejected by condenser. Now the heat rejected by condenser is basically kind of a device where there is no work done. It's just the heat exchanger kind of a device where the heat is rejected to the ambient atmosphere, and the heat rejected is basically the change in enthalpy of the refrigerant. So the change in enthalpy of the refrigerant is mass of the refrigerant circulated minus the decrease in the enthalpy because it loses out heat to the ambient. It's basically the back side of your refrigerator where you have the entire tubular structure of mostly in the black color. So this H2 minus H3 is what you know. So now mass circulation rate is given. H2 is basically Hg at 40 degrees Celsius minus H3 is basically the HF, that is the liquid part at the same 40 degrees Celsius. So these two you can get from the table. So mass circulation rate is 0.025, and from the table the Hg is 200 at 40 degrees and HF is 80. So let's look at the table. I mean this is what we use, 80 and 20. So 80 and 20 I have used. Sorry about that. We are using basically this HF and Hg at the same temperature of 40. So these two are used for the first data, and we get 120 into 0.025. So if you multiply it, basically is 3 kilowatt. So this is kilojoules per second, so it becomes kilowatt. 3 kilowatt is the heat rejected. So this is first part of the common data. So let's see the second part. Thank you.